Need extra money for college? ISL Education Lending Scholarship Program provides $1,000 for college expenses. Registration is easy and no essay is required. Visit www.iowastudentloan.org/register to learn more. The scholarship is open to Iowa residents who are in high school and college students, as well as parents of those students. Register by November 30th for your chance at one of the 45 awards at www.iowastudentloan.org/register.
We can stop HIV, Iowa.
And it all starts with health equity.
Health equity means that everyone has a fair and just opportunity to be healthy.
To achieve this, we need to remove obstacles to good health.
Poverty and discrimination support an environment in which HIV thrives.
We must work together so that all Iowans have access to the resources they need to prevent, diagnose, and to treat HIV.
Visit stopHIViowa.org.
This is SpaceTime Series 24, Episode 11. Coming up on SpaceTime, how the asteroid Ryugu lost its water, NASA's SLS Moon rocket core stage fails its engine test, and work starting to accelerate on the Lunar Gateway space station. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
As scientists continue to sift through the treasure trove of rocks, grains and dust brought back to Earth last month by the Hayabusa 2 mission to the asteroid Ryugu, other researchers are going through the petabytes of remote sensing data collected during the mission to reveal new details about the asteroid's past. Now, a report in the journal Nature Astronomy has provided an explanation for why Ryugu isn't quite as rich in water-bearing minerals as some other asteroids. The findings suggest that Ryugu's ancient parent body must have undergone some sort of heating event before Ryugu formed. One of the study's authors, Ralph Millikan from Brown University, says one of the reasons Ryugu was chosen for the sample return mission was its dark colour, suggesting it belonged to a class of asteroids suspected of having water-bearing minerals and organic compounds. Water-bearing asteroids are thought to have played a significant role in delivering life-giving water to Earth early in the solar system's history. So, understanding the distribution of water in the ancient solar system has become a priority. In the search for life, the mantra has often been, follow the water. Asteroids like Ryugu are thought to be the parent bodies of dark water and carbon-bearing meteorites found on Earth, known as carbonaceous chondrites. Carbonaceous chondrites are among the most primitive of all known meteorites, often dating back to before the creation of our solar system 4.6 billion years ago. Their compositions contain CaIs, or calcium-aluminum-rich inclusions, thought to be the very first solids to condense out of the protoplanetary disk, which would eventually form our Sun and solar system. In fact, some even more ancient CaIs predate the solar system's creation completely, and are thought to have been produced by the supernova event which triggered the gravitational collapse of the molecular gas and dust cloud which formed our Sun and solar system in the first place. In fact, the Murchison meteorite, which fell to Earth in 1969 near Murchison, Victoria, included silicon carbide particles which Philip Heck and colleagues from the Field Museum of Natural History in Chicago dated to over 7 billion years of age. That's more than 2.4 billion years older than the Sun and solar system. Carbonaceous chondrites often contain a high percentage of water-bearing minerals, up to 22%. They also contain a rich mix of complex organic compounds, such as polycyclic aromatic hydrocarbons or PAHs and amino acids, the building blocks of proteins, and ultimately life. In fact, the Murchison meteorite was found to contain over 70 different types of amino acids. Most carbonaceous chondrite parent bodies are thought to be less than 100 kilometers in diameter. Many contain a high percentage of primitive volatile compounds, indicating that they are condensed in the outer cooler portion of the solar nebula. Yet others are relatively poor in volatile compounds, and that suggests their parent asteroids experience significant heating. Carbonaceous chondrites are fairly rare, making up less than 5% of all meteorites. But these include some of the most famous of all meteorites, including the Murchison, the Allende, the Tagish Lake, and the Sutter's Mill meteorites. While carbonaceous chondrites have been studied in great detail in laboratories around the world for many decades, it's still not possible to determine with any certainty which asteroid a given carbonaceous chondrite meteorite may have originated from. The Hayabusa 2 mission represents the first time a sample from one of these intriguing asteroids has been directly collected and returned to Earth. But observations of Ryugu made by Hayabusa 2 as it flew alongside the asteroid suggest it may not have been as rich in water as scientists originally expected. There are several competing ideas for how and when Ryugu may have lost some of its water. Ryugu is a rubble pile, in other words a loose conglomeration of rock simply held together by gravity. And scientists think these sorts of asteroids likely form out of debris left over when a larger, more solid asteroid is broken apart in a large impact event. So, it's possible that the water signature seen in Ryugu today is all that remains of a previously more water-rich parent asteroid that dried out due to some sort of heating event of some kind. But it could also be that Ryugu itself dried out following a catastrophic disruption and then its reformation as a rubble pile. It's also possible that this 900-metre wide asteroid may have had a few close passes of the Sun in recent history, which could very well have heated it up and dried out its surface. During its rendezvous with Ryugu, Hayabusa 2 fired 2 small projectiles into the asteroid's surface. The impacts created small craters and exposed rocks buried in the subsurface. Using a near-infrared spectrometer aboard the spacecraft, which is capable of detecting water-bearing minerals, researchers could then compare the water content of the surface rock with that of the subsurface. And the data showed that the subsurface water signature was very similar to that of the outer crust. And that means the findings are more consistent with the idea that Ryugu's parent body must have dried out, rather than a scenario in which Ryugu's surface was dried out by the Sun. This is SpaceTime. Still to come, NASA's new SLS Moon rocket suffers an engine failure during its first test, and work speeds up on development of the Lunar Gateway space station. All that and more coming up on SpaceTime. This episode of SpaceTime is brought to you by LastPass, simplifying your online life. Now, if you're anything like me, one of the biggest frustrations and time-consuming parts of going online anywhere is trying to remember and then use all those login details and passwords that you've built up over the years. And again, like me, you probably already have hundreds of them. Of course, on the other hand, you could just be like a lot of other people out there and simply use one password for everything, and that's not a particularly secure idea. But I guess it could be worse. You could be one of those people that use 1, 2, 3, 4, 5 or A, B, C, D, E, or worst of all, you could use password as your password. And with the internet getting more and more dangerous, now really is the time to do something about that. And the good news is there's a great solution out there. It's called LastPass Password Manager. And with it, suddenly all those security hassles are gone. And believe me, the relief really is unbelievable. Not to mention the time it saves you. And it's so convenient having everything stored in the one manageable dashboard. If you sign up for LastPass, you'll be joining some 25.6 million fellow users around the world and more than 70,000 businesses. Now, you've got to admit, that's a lot of trust with one of the most important aspects of online life. And the good news is, all this peace of mind is really affordable. If you want, you can simply sign up for the free service and leave it at that. Or for even more features, get the premium package, which is $4.50 a month. There are family and enterprise plans available as well. Plus, LastPass works across all devices and even suggests super secure passwords for you to use. So, why not put your passwords into autopilot and reduce the stress? You can check out LastPass at spacetimewithstuartgary.com/LastPass. That way, you'll be helping to support our show. So sign up and use it for free at spacetimewithstuartgary.com/LastPass and simplify your life. And like always, you'll find the link details in the show notes and on our website. That's spacetimewithstuartgary.com/LastPass. And now, it's back to the show.
This is SpaceTime with Stuart Gary.
NASA's plans to return humans to the lunar surface have suffered a major setback, with the first attempt to light up all 4 main engines of its new SLS Moon rocket being aborted just a minute into the 8-minute test firing. The The hot fire test on the stand at NASA's Stennis Space Center in Mississippi shut down just 67 seconds after ignition when the hydraulic system for one of the engines exceeded computer safety parameters. The Boeing-built 64-metre-tall core stage of the SLS is equipped with 4 Aerojet Rocketdyne RS-25 space shuttle main engines, designed to burn liquid hydrogen and oxygen for the 8.5-minute ride to orbit.
For all personnel, report that you're ready to go. PEA. Go. AEA. HEA. Go. REA. Go. NTC. We're go. All right, we're in ALS. There we go. Engine start. And we're in the plus count. Engine start. We're in the plus count. Call for South, please continue to monitor your system. And grass is in control. All right, plus 25 seconds. DDRA, we did get an MCF on engine 4. Copy that, but we're still running. Still got 4 good engines, right? Got that. All right. It passes through 60 plus 60 seconds. Get into our first gimbal profile.
BTD, SFC.
Gotcha.
CCC violation, correct?
And we got a shutdown. All personnel. Shutdown looks like all personnel. It's going to be post-hot fire or shutdown securing operations.
BTD, I need you to verify with the engine guy.
Yeah, sorry about that.
Shutdown standby.
Look at that. All personnel, that does take us to the last page there on page 632. AR1, if you would, on step 4.241, please verify core stage engine 1s and 4 have shut down for that step, and we have a safe engine shutdown.
We are in post-shutdown standby, engines 1 through 4.
Obviously, we had a very successful initiation of the engines. The beginning of our thrust profile there when we were firing for the first minute or so, we obviously were getting some really good data coming through. But like we said earlier, this is a test. We have test commit criteria, and we have certain boundaries that we have to keep all the operations under. So we really are trying to make sure that everything's operating properly and safely. So the test team was kind of seeing some data that they might not like, and so our engines were shut down ahead of the 8-minute scheduled time frame. But we do have a lot of good data to go look at, and hopefully we can move on from here and maybe see what's going to go on further. So, right, and so just like all of our other green run tests, we have teams that are going to go and break down that data and kind of see what we're seeing in our profiles, right? And so that all goes into the profile that we'll use for launch eventually at Kennedy. So obviously there's a lot of things to look at the data. We have roughly 800 terabytes of data, and that's a lot of data. We're talking about it's hard to grasp how much data that is. So we'll obviously take the time to dig through everything, and then obviously have a path forward from there.
NASA says it can adjust the test limits to prevent another premature shutdown. Engineers, meanwhile, will continue analysing the data before deciding on the next step. The 2-stage SLS, or Space Launch System, is the world's most powerful rocket, on par with the famous Saturn V Apollo moon rocket of the 1960s and 70s. Its maiden flight on Artemis 1, which is slated for launch in November, will carry an unmanned Orion capsule on an extended journey around the moon. That test flight will be followed by the Artemis 2 manned mission to lunar orbit in 2023. And then the historic return of humans to the surface of the moon aboard the Artemis 3 mission, which is slated for 2024. The SLS main engines used for the test have all already been flight proven on space shuttle missions. So exactly how this setback will affect the launch schedule for Artemis 1 is yet to be determined. When it does fly, Artemis 1 will test just about all the systems needed for a manned moon mission. This report from NASA TV.
In the next 8 minutes, you'll experience a 25.5-day mission from rollout to recovery. The first integrated flight test of the Orion spacecraft and the Space Launch System rocket launching from the Kennedy Space Center is about to unfold. This is the first of many missions to come that will use the Deep Space Exploration System to prepare our team, our ship, and our astronauts for human operations in deep space. Rollout from the Vehicle Assembly Building signals that launch is near. Sitting atop the mobile launcher, the crawler transporter moves along the crawlerway towards historic Launch Pad 39B at the Kennedy Space Center at a top speed of 1 mile an hour. After traveling over 4 miles, the rocket and the spacecraft climb up a ramp and are positioned over a flame trench. Once in position, the mobile launcher is lowered onto support post and the crawler is rolled away to a safe distance. Final checks are performed at the pad, including crew cabin closeout via the access arm sitting over 300 feet above the surface of the launch pad. The launch date is set, and the teams are prepared for the mission that is about to occur. It's sunrise on launch day. Engineers in the Launch Control Center have already powered up the spacecraft and the rocket and loaded the core stage and upper stage with cryogenic fuel. As launch window open approaches, final checks are performed, and when all systems are go, terminal countdown is initiated. The big physics of launch are about to be put on full demonstration. Umbilical plates weighing hundreds of pounds await their cue to retract to clear the path of the rocket at liftoff, some mounted on arms the size of tractor-trailers. The mighty core stage engines are prepared for engine start as they are thermally conditioned for an onrush of cryogenic fuel in the heat of ignition. At T-minus 15 seconds, sound suppression is activated, cascading water into the flame trench to dampen the acoustic shock, and as the core stage engines achieve full throttle, shock diamonds appear. At booster ignition, the flame trench is flooded with fire. At first motion, all umbilical arms are retracted, and the rocket clears the tower in just seconds. At liftoff, the vehicle produces 8.8 million pounds of thrust and lofts the vehicle weighing nearly 6 million pounds and standing 32 stories tall to orbit. Propelled by a pair of 5-segment boosters and 4 liquid engines, the rocket achieves maximum dynamic pressure only 90 seconds into the mission, the period of greatest atmospheric force on the structure of the rocket. Thousands will gather in Florida to watch our ship get smaller and smaller and leave the Space Coast behind. Approximately 2 minutes into the mission, the boosters will have consumed all of their solid propellant and are safely jettisoned. The rocket will continue on, guiding itself to orbit with magnificent precision. Just 3 minutes into the mission, the service module fairings are jettisoned to lighten the vehicle and expose Orion's solar arrays. Just 40 seconds later, the launch abort system is also jettisoned. It is no longer needed. Orion could safely abort at any time. Once at the desired velocity target, the core stage engines are shut down and the core stage separates. The interim cryo-propulsion stage with Orion will continue to orbit the Earth. Along the way, they will pass through the altitude of the International Space Station at 250 statute miles. During this first orbit, the solar arrays are deployed so that Orion no longer needs battery power. It can now produce its own power. Following solar array deployment, the arrays are positioned into a load-bearing configuration to prepare for the perigee raise maneuver. The raise maneuver will ensure an Earth orbit and use the thrust provided by the interim cryo-propulsion stage. Once the perigee raise maneuver is complete, Orion systems are checked prior to committing to the translunar injection, or TLI maneuver. The TLI maneuver must be successfully completed to depart Earth orbit. The TLI burn is approximately 20 minutes in duration and increases the spacecraft's velocity over 9,000 feet per second, a speed change faster than a high-powered rifle bullet travels. Following TLI, Orion is committed to a lunar trajectory, just 1.5 hours after launch. Once complete, the spacecraft adapter will remain with the interim cryo-propulsion stage, and they will separate from Orion. As Orion departs low Earth orbit, it will fly through the orbital debris field encircling the Earth, past the global positioning navigation satellites, past the communication satellites in geostationary orbit, and through the Van Allen radiation belts, on into the deep space radiation environment. Orion is now entering an outbound coast phase. The spacecraft is uniquely designed to navigate, communicate, and operate in this deep space environment. The outbound coast to the Moon will take approximately 4 days. As Orion approaches the Moon, the service module will be used to perform a critical lunar gravity assist maneuver, allowing the ship to enter a distant retrograde orbit about the Moon. The Moon will get larger and larger in the window, and at closest approach, Orion will be just 62 miles from the surface of the Moon. As the spacecraft flies around the far side of the Moon, we will lose all communication back on Earth, and for a period of time, Orion will be on its own. Mission Control will await acquisition of signal, and as we lock on, a new generation will see their first Earthrise. The spacecraft is now in the distant retrograde orbit, where its systems will be tested in the deep space environment for over a week. Along the way, our ship will travel farther from Earth than any human-capable spacecraft has ever gone. At the farthest point, Orion will be some 1,000 times farther from Earth than the International Space Station, at over 270,000 miles away. Teams in Mission Control Houston and at Naval Base San Diego will prepare for Orion's return home, and the recovery ship will set sail for the recovery zone in the Pacific Ocean. Orion will exit the distant retrograde orbit with another lunar gravity assist and service module engine firing. Along the way, the trajectory will be adjusted to target the Earth's thin atmosphere at over 250,000 miles away and ensure a precision landing in the Pacific Ocean following a direct entry. During the coast home, Orion will maintain the desired tail-to-sun attitude to optimize spacecraft cooling and maximize power production in the deep space environment. Another 4 days return coast home to Earth. As our home planet fills the windows of Orion, an important contribution from our European partners called the service module has done its job. The service module is jettisoned and separates. Following separation, the world's largest heat shield will be oriented into the direction of travel to prepare for entry interface at an altitude of 400,000 feet. At entry interface, Orion will hit the Earth's atmosphere traveling at a speed of 24,500 miles an hour and decelerate at up to 9 times the force of gravity. The heat shield will protect the spacecraft from temperatures half as hot as the surface of the Sun, approaching 5,000 degrees Fahrenheit. Orion will continue to decelerate, pass through the sound barrier, and announce its arrival to the waiting recovery team with a sonic boom. Following peak heating, a protective thermal cover that sits over the parachutes will be jettisoned. This begins a series of parachute deployments. The drogue chute deployment series is designed to stabilize and slow the spacecraft, and in a period of less than 20 minutes, Orion will slow from a speed of Mach 32 to 0 at splashdown. The 3 main parachutes will deploy and slowly unfurl and suspend the 22,000-pound capsule and allow it to gently descend to the surface of the ocean. After 25 and a half days, and a total distance traveled exceeding 1.3 million miles, a precision landing within eyesight of the recovery ship. Following splashdown, Orion will remain powered for a period of time as Navy divers approach in small boats from the waiting recovery ship. After a brief inspection for hazards, the divers will hook up tending lines and a tow line. The capsule will be then towed into the well deck of the recovery ship, and once the capsule clears the stern gate, the gate will be closed, the well deck will be drained, and we will bring our ship home.
This is Space Time. Still to come, work speeding up on the Lunar Gateway space station project, and a new app to help you find your way across the sky. All that and more still to come on Space Time. The European Space Agency has signed formal contracts with Thales Alenia Space to start building the new European Esprit module for the new Lunar Gateway space station. The space station will be positioned in trans-lunar orbit between the Earth and the Moon and will act as a staging post for manned missions down to the lunar surface. The first modules will need to be in place for the Artemis 3 mission, slated for 2024, which will return astronauts to the lunar surface. Like the International Space Station, Gateway will be built out of separate modules constructed on Earth, and then flown up to an assembly point where they'll be attached to each other. Esprit stands for the European system providing refuelling infrastructure and telecommunications. The €296.5 million cylindrical module will have room for astronauts to work in, much like an International Space Station module. It'll include an observatory offering 360-degree views of the Moon, as well as spacecraft as they dock with the lunar outpost. Esprit will consist of 2 main elements: a system to provide data, voice and video communications from the Gateway space station to the Moon, and a refueling module that will provide Gateway with xenon and chemical propellants. The refueling element will ensure Gateway has fuel for maintaining its own orbit, as well as supporting future reusable lunar landers and future deep space transports. ESA is also working with the Japan Aerospace Exploration Agency JAXA to build the International Habitation Module IHAB. Meanwhile, the Russian Federal Space Agency at Roscosmos will construct a crew airlock which will be attached to IHAB, and the Canadian Space Agency is building the space station's robotic arm. For its part, NASA is constructing the power and propulsion element as well as the Central Habitation Module HALO. HALO stands for Habitation and Logistics Outpost. NASA will also be responsible for logistical supply craft, manned lunar landers, and the Orion spacecraft attached to the European Service Module, which will be used to transport crew to and from the Earth. Esprit's communications elements under fast-track development for launch in 2024 mounted on the HALO module, while the refueling module will be launched in 2026. Thales Alenia Space is already responsible for more than half the volume of the International Space Station, and the new Esprit contract means the company is now working on most of the Gateway modules, including the ESA-JAXA IHAB module, and providing the primary structure for NASA's HALO module in partnership with Northrop Grumman. The company is also providing the first 2 modules of the new Axiom commercial space station. Axiom hopes to attach its first module to the International Space Station in 2024, followed by at least 2 more modules at 6-month intervals. Eventually, sometime around 2028, the company will attach its own power and support systems, its own docking modules, and its own robotic arm. That will allow the Axiom section to be detached and operate independently of the International Space Station once the space station's deorbited in 2030. This is Space Time. Still to come, if you've got a telescope, there's a new app which will help you find your way across the sky. And later in the science report, it's been revealed most Australians will be offered the Oxford AstraZeneca vaccine for COVID-19 rather than the Pfizer-BioNTech jab. All that and much more still to come on SpaceTime. There's a new app which makes it easier than ever to find your way across the sky. You just type in what celestial object you're looking for and it will literally point you in the right direction. With the details, we're joined by Jonathan Alley, the editor of Australian Sky and Telescope magazine.
We have a review of a great new kind of telescope system that makes it easy for anyone to home in on fascinating sights in the sky. All you need is what's called a StarSense Explorer telescope and a mobile phone, and you're on your way. All you have to do is you download the app onto your phone, you place your phone in the special cradle that's on the telescope, that's lined up with the telescope, and you switch on your phone's camera. And the app just does the rest. What it does is it takes a picture of wherever the telescope is pointed, it works out where the telescope is pointed due to the star patterns that it can see, and then you tell it what you want to see, and it'll say, righto, it'll put a big bunch of arrows on the screen. So if you need to move the telescope to the left, there'll be this big arrow pointing to the left. And you just move the telescope to the left, and it might have an arrow going up to the up as well. So you move the telescope up, and when the arrows disappear, when they shrink down, and when they disappear, it means you're getting closer, closer, closer. And when the arrows disappear, it means you're pointing exactly at the thing that you wanted to see. Isn't that brilliant? You don't have to have thousands of dollars worth of super duper telescope gear. Just one of these telescopes with a little cradle on it. Stick your phone in, get the app, and off you go. So if you want to see a particular star or galaxy or planet or a deep sky object, you just tell it what you want to see and it'll tell you which direction to move the telescope. And you just move it until the picture on the screen of your phone or the little arrows disappear, and look through the telescope then, and there you have it. It's really great. It makes astronomy so easy for absolute beginners. It's certainly a lot easier to use than the telescopes that were around when I was a kid, when you had to just do everything manually and you're going off books and star charts and things.
And hiding from dinosaurs and things at the same time, yeah.
I didn't hide from dinosaurs, I was brave.
That's Jonathan Alley, the editor of Australian Sky and Telescope magazine. And don't forget, if you're having trouble getting your copy of Australian Sky and Telescope magazine from your usual retailer because of the current lockdown and travel restrictions, you can always get a print or digital subscription and have the magazine delivered directly to your letterbox or inbox. Subscribing's easy. Just go to skyandtelescope.com.au. That's skyandtelescope.com.au, and you'll never be left in the dark again. This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with the Science Report. Australia's Chief Medical Officer, Professor Paul Kelly, says most Australians will be offered the Oxford AstraZeneca vaccine rather than the Pfizer-BioNTech jab. The federal government has agreements to receive 53.8 million doses of the Oxford AstraZeneca vaccine and some 10 million doses of the Pfizer shot. The two vaccines induce immunity in different ways. They both train the body's immune system to recognize and respond to a spike protein used by the SARS-CoV-2 coronavirus. The Oxford AstraZeneca vaccine is a traditional tried and tested method, using inactivated proteins from an adenovirus to provoke the immune system into mounting a response. The modified RNA Pfizer vaccine is a new approach, using synthetic proteins to get the body to produce some of the viral proteins, which then trigger the immune response. Getting the human body to produce the viral proteins itself means the mRNA vaccine reduces manufacturing processes, which means it should be easier and quicker to produce than traditional vaccines. Initial Phase 3 trials show that both types of vaccines are effective, the Pfizer vaccine having an efficacy of between 93.7 and 94.5% from 2 jabs given 3 weeks apart. The Oxford AstraZeneca jab's more complicated. It's said to protect around 70% of people. But it's not that simple. It all depends on the optimal dose and timing of the Oxford shot, which remains unclear. One trial showing 62% protection from 2 full doses given 4 weeks apart, while another trial found 90% efficacy when given a low dose for the first shot and then a longer gap of up to 12 weeks before a full dose for the second shot. The other big difference is that the Pfizer vaccine needs to be stored and transported at minus 70 to 80 degrees Celsius, so it requires special equipment. That means it'll only be given out from hospital vaccination centres. On the other hand, the Oxford vaccine can be transported and stored through normal refrigeration at 4 degrees Celsius, so it'll be available through your family doctor. The 10 million doses of the Pfizer vaccine will be prioritised for frontline workers, senior citizens, and those with high-risk health conditions. The Oxford vaccine, 50 million doses of which are being made locally, will be given to the rest of the population. Australia also has an agreement for the Novavax vaccine, which is currently in phase 3 trials. And Canberra is also part of COVAX, which is developing a number of other COVID-19 vaccines. More than 2 million people have now died, and over 100 million have now been infected by the COVID-19 pandemic, which spread globally out of its Wuhan epicenter after the Chinese government ordered local doctors to lie about the seriousness of the deadly disease. Well, if you suffer from atrial fibrillation, here's a story to make your heart flutter. A new study has found that as little as one small alcoholic drink a day could cause an increase in the risk of atrial fibrillation. Atrial fibrillation, or AFib, is an irregular, often rapid heart rate in the upper chambers of the heart that beat out of sync with the bottom chambers. The end result is turbulence, which can cause clotting, and that can cause a stroke, which can be fatal. The new findings, reported in the European Heart Journal, are based on a study of 108,000 patients and shows that as little as a single alcoholic drink per day increased the person's risk by 16% over 14 years compared to a teetotaler. Archaeologists have discovered what may be the world's oldest cave paintings, dating back some 45,500 years. The paintings were uncovered in Indonesia's South Sulawesi during field research. A report in the journal Science Advances claims the cave paintings show a figurative depiction of a Sulawesi warty pig, a wild boar native to the island. The previously oldest dated rock art seen, around 43,900 years old, was a depiction of hybrid human-animal beings hunting Sulawesi warty pigs and dwarf bovids, discovered earlier by the same archaeological team in a nearby limestone cave. A new study has recommended getting kittens desexed before the age of 4 months rather than the 6 months previously recommended. The findings, published in the journal Scientific Reports, follows research by the University of Sydney, which found that closing the pregnancy gap between puberty and surgery could lessen the impact of unwanted litters. Around 83% of domestic cats presented to veterinarians in Australia are desexed, which is among the highest rates internationally. However, the study also found that desexing at 4 months or younger was carried out in only 21.5% of female cats, and only 59.8% of female cats had been desexed by 6 months of age, the traditional and most commonly recommended time by vets in Australia. Well, earlier this week, Alex Harovroit from ITY.com told us about some of the more exotic technology on display at this year's CES, the world's largest consumer electronics show. This year's event, which was virtual because of the COVID-19 pandemic, didn't just feature flying cars and robot servants, which the well-to-do will be checking out. It also showcased the latest versions of technology that you'll probably end up buying in the next few years, including your next TV.
They had a 110-inch 4K TV, sells for $150,000. It uses micro LED technology. So that's similar to OLED TVs, where each pixel emits its own light source organically. That's what the O in OLED stands for. But micro LED guarantees a brighter light source than OLEDs can deliver, and it's meant to be at a cheaper price. Now, LG, who is the master at OLED displays, introduced a new form of OLED display this year where they're little OLED pixels. Each pixel is meant to be 20% brighter. So as one company comes up with a better way and a brighter way to deliver TV images pixel by pixel, the other company also is working on similar technology. But it just means that for the most part, this will filter down over the next 4 or 5 years into the $300-400 TVs, and everybody will get them.
And it wasn't just new TVs. Samsung have introduced their latest Galaxy, the S21 S21. That was only 11 months ago. They brought out the S20.
Yeah, well, look, obviously Samsung is in a big battle every year with Apple for the latest and greatest. Now, the Samsung has launched 3 new devices, the S21, the S21 Plus, and the S21 Ultra. The S21 Ultra has the best cameras, the biggest screen. It also, for the first time in an S-series device, has compatibility with the S Pen. It doesn't come with an S Pen. You have to buy one separately, or you can use the S Pen from your Note or Galaxy tablets that already came with an S Pen, and you can buy a case that has a slot to put the pen into. Obviously, Samsung has improved its processor as well. It now has a 5-nanometer processor, which is the smallest current design for processors, although Apple is supposed to come out with a 3-nanometer processor later this year. And the top-of-the-line Samsung S21 Ultra not only comes with 512 gigabytes of storage, but a whopping 16 gigabytes of RAM, which is truly incredible. I think the top-of-the-line iPhone only has 6 gigabytes of RAM, but of course Apple is very good at making its hardware and software work together so that it doesn't need more memory. But one thing that Samsung did do was they got rid of the SD card slot, the micro SD card slot, which has annoyed a lot of people who like to have 512 gig or 1 terabyte SD cards in their phones to store all their photos and videos. And also, even though Samsung mocked Apple for not including a charger with its iPhone 12 devices, Samsung with it has done the same.
What about the price? Do we know the prices yet?
It starts at $799 US for the Galaxy S21 with 128 gigabytes. The S21 Plus starts at $999, and the S21 Ultra starts at $1199 in the US. Australian prices start at $1249 for the 128 gig Galaxy S21, $1549 for the Galaxy S21 Plus, and $1849 for the Galaxy S21 Ultra. And prices go up if you want models with 256 gig or 512 gig for the S21 Ultra. Other things we saw included wearable displays. TCL is going to make a wearable display that looks like a pair of glasses but has twin 1080p screens in front of your face that's sort of like 140-inch, about 4 meters in front of your eyes. They also have a new pet GPS tracker for your dog. It's got a little QR code on the display. 14 days of battery life. You can set up zones so if the dog goes out of that zone, it'll alert you on your phone and you can find out where the dog is. The Samsung has a solar-powered remote control. You know, remote controls are run out of battery. But here, if you turn the remote control so that its buttons are facing down, on the back of it, it has a solar panel, which is charging the remote. And instead of having to worry about putting in AA batteries, it has a lithium-ion battery and it just charges up via the standard USB-C port that you have on most different phones.
Yes, but how's it going to charge anything when it's hidden under the couch cushion?
Well, that's where you use your mobile phone and a Samsung app as a way to not only control your television, but also to find your remote control. We also saw dual-screen laptops at CES. Now, Asus was the first to come out with a dual-screen laptop. Intel also did this last year. They had a demo version of this. It is cool that you would have it in your laptop, and I have seen in years gone by laptops that had screens that folded out, but it does make your laptop bigger and bulkier. And if you already have an iPad or an Android tablet, it is possible to mirror or extend your screen onto those devices. So having laptops with dual screens, multiple screens, is definitely very cool. But if it adds too much weight, it's not something that it will necessarily take off.
That's Alex Zaharov-Reut from ITY.com. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favorite podcast download provider, and from SpacetimeWithStuartGary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to SpaceTimeWithStuartGary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to SpaceTimeWithStuartGary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel. And on Facebook, just go to facebook.com/spacetime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.